Welcome to the Shikasa Boo Motor channel. This channel provides easy-to-understand explanations of car mechanisms. Since Renault has the French government as a major shareholder, it can unequivocally be considered a French company. Therefore, the hybrid system installed in the Renault Austral E-Tech can be described as a French hybrid. Meanwhile, Peugeot is now part of the Stellantis group, and the hybrid system in the 3008 is a shared powertrain used across other group brands, including Citroën, Fiat, Alfa Romeo, and Jeep. Therefore, its classification as a French hybrid is open to interpretation. However, there is no doubt that Peugeot is a French brand. So we will frame the comparison between the Renault Austral E-Tech and the Peugeot 3008 hybrid as a French hybrid showdown. To put it very simply, Peugeot's hybrid system combines a 6-speed DCT with a low-output electric motor, while Renault's system pairs the engine with a 4-speed transmission and a high-output electric motor with a 2-speed transmission. Let's take a look at the specifications. The figures in the table are sourced from both manufacturers' UK websites, except for the fuel economy data for the Austral. Both vehicles are in the same price range. They also have very similar gross vehicle weights, and both are powered by a 1.2-liter 3-cylinder turbo engine. These make an ideal comparison for highlighting the differences between hybrid systems. Renault's hybrid system features a unique architecture, with 2 electric motors, utilizing a 4-speed transmission for the ICE, internal combustion engine, and a 2-speed transmission for the traction motor. The ICE is connected to an engine shaft equipped with a gear. A traction motor equipped with 2 gears is positioned coaxially with the engine shaft. The engine shaft gear is connected to the HSG, high-voltage starter generator, via a countershaft gear and an idler gear. An output shaft equipped with 3 gears is connected to the differential. A 2-speed shifting mechanism is provided on each of the engine shaft, countershaft, and output shaft. The H5F B6 engine is a 1.2-liter, 3-cylinder turbocharged engine, producing a maximum output of 96 kilowatts and a maximum torque of 205 Nm. The traction motor has a maximum output of 50 kilowatts and a maximum torque of 205 Nm. The hybrid battery has a voltage of 400 volts and a capacity of 2.0 kilowatt-hours. Let's look at how it operates. When the vehicle is stationary, the output shaft's shifting mechanism engages the low gear, selecting first gear for the traction motor. The ICE is not operating. When the driver presses the accelerator pedal, the motor speed increases and the vehicle launches in EV mode. Depending on driving conditions, the output shaft shifting mechanism engages the high gear, putting the traction motor in second gear. When the vehicle's speed exceeds a threshold, the HSG acts as a starter motor to start the ICE. At this time, the engine shaft's shifting mechanism is in the neutral position. Once the ICE starts, the system switches to ICE mode. The engine shaft's shifting mechanism engages the low gear, selecting second gear for the ICE. As the vehicle's speed increases, the system shifts to ICE third, and then to ICE fourth gear. While Renault's documentation does not specify the exact timing for ICE first gear, it is presumed to be used during rapid acceleration or on extremely steep gradients. When strong acceleration is required, the system switches to parallel hybrid mode. The traction motor assists the ICE, delivering high torque. Depending on the driving conditions, the ICE's 4 speeds and the drive motor's 2 speeds are optimally combined. This system can also function as a series hybrid. The engine shaft's shifting mechanism is set to neutral, allowing the ICE to operate exclusively as an HSG-driven unit. The electricity generated by the HSG is supplied to the traction motor via the traction inverter. At this time, the ICE does not contribute to driving the vehicle. During regenerative braking, the engine shaft's shifting mechanism is set to neutral, while the output shaft's shifting mechanism is engaged in the low gear. The traction motor acts as a generator to charge the hybrid battery and produce braking force. The Peugeot 3008's hybrid system is much simpler than Renault's, yet its transmission structure is quite complex. This is a conceptual diagram of the system. This system consists of a C0 clutch for disconnecting the ICE from the drivetrain, a traction motor, a 6-speed DCT, dual clutch transmission, and a BSG, belt-driven starter generator. The EB2LT EDH2 engine is a 1.2-liter, 3-cylinder turbocharged engine, producing a maximum output of 100 kilowatts and a maximum torque of 230 Nm. The traction motor has a maximum output of 16 kilowatts and a maximum torque of 51 Nm. The hybrid battery has a voltage of 48 volts and a capacity of 0.9 kilowatt-hours. The DCT features a highly unique structure, in which the odd-numbered gear side is equipped with a reduction mechanism, using a planetary gear set. Peugeot has yet to disclose the full technical details of this transmission. Based on the available data, let's envision its internal structure and operating principles by modeling it as a 2-speed DCT. If you're not familiar with how a conventional DCT works, please check out this video. You can find the link in the description below. The C0 clutch is positioned on the ICE output shaft. Its outer case is permanently geared to the traction motor. The C0 clutch output connects to the ring gear of the planetary gear set. One of the first and second gear shafts is connected to the C2 clutch inner hub, while the other is linked to the planetary carrier. The sun gear is linked to the C1 clutch, and when C1 is engaged, the sun gear is locked to the transmission case. Rotation from the first and second gears is transmitted to the differential via the countershaft. A 48-volt BSG handles engine starting and power generation. When the vehicle is stationary, the C0 and C2 clutches are disengaged, the C1 clutch is engaged, and the ICE is stopped. When the driver presses the accelerator pedal, the motor's rotation is transmitted to the ring gear of the planetary gear set. Because the C1 clutch is engaged and the sun gear is held stationary, the planetary carrier outputs at a reduced speed. The rotation is transmitted to the differential via the first-second gear and the countershaft. This is the first gear of EV mode. Once the vehicle speed reaches a predetermined threshold, the system disengages C1 and engages C2. The motor's rotation is transmitted to the first-second gear, without being reduced by the planetary gear set. Therefore, the gear rotates at a higher speed than in first gear. This is the second gear of EV mode. In this way, the DCT achieves two-speed operation using a single gear set, without the need for physical gear shifts. As the vehicle speed increases further, the BSG acts as a starter motor to crank the ICE. By stopping the traction motor and engaging the C0 clutch, the system transitions to the second gear of ICE mode. Since the actual 3008 utilizes a 6-speed DCT, it achieves the full range of gears by expanding on this operating principle across multiple gear sets. However, as mentioned earlier, Peugeot has not disclosed the full details of this DCT. From here on, the rest is left to your own imagination to explore and enjoy. One question remains. In a typical parallel hybrid system, only one electric motor is installed. In EV mode, the motor propels the vehicle. During engine start, it acts as a starter. And in ICE mode, it functions as a generator to charge the battery. However, the system in the 3008 features two electric motors, a traction motor and a BSG. Why did Peugeot incorporate two components that seemingly serve the same function? A possible clue may lie in a special edition of the CX-60 that Mazda temporarily introduced to the Japanese market in 2025. The CX-60's mild hybrid system features a 3.3 liters turbocharged diesel engine, an 8-speed automatic transmission, and a 48-volt traction motor, along with a conventional 12-volt starter motor. The 12-volt starter motor is used when the 48 volts battery voltage is low, or when maximum output is required. In the special edition model, the control strategy has been revised so that the 12-volt starter motor is also used to start the engine during EV mode at speeds of 50 km per hour or below. The reason is to improve fuel efficiency. This model achieves a half a kilometer per liter improvement in WLTC fuel economy over the standard version. This suggests that requiring a single 48-volt motor to handle both propulsion and engine starting may impose an excessive load, hindering overall efficiency and negatively impacting fuel economy. The 3008's traction motor delivers a peak output of 16 kilowatts, while the CX-60's is 12 kilowatts. Generally, 12-volt starter motors have an output of approximately 1 to 2 kilowatts. This means that in a 48 volts mild hybrid system, roughly 10 to 20% of the motor's total output must be dedicated to engine starting. From this perspective, the reason Peugeot chose to install a separate BSG becomes clear. Of course, this remains a hypothesis. The truth is known only to Peugeot's engineers. Now, let's go back to the spec sheet. With similar vehicle weights, price ranges, and ICE performance, it's fair to say that most of the functional differences between these two vehicles stem from their respective hybrid systems. First, we'll consider the performance difference between their traction motors. The 3008's motor produces a maximum output of 16 kilowatts and maximum torque of 51 Newton meters, whereas the Austral delivers 50 kilowatts and 205 Newton meters. Given that the 3008 utilizes a 48-volt system, while the Austral operates at 400 volts, this gap is only to be expected. Furthermore, the 3008's battery capacity is 0.9 kilowatt-hours, while the Austral is equipped with a 2.0 kilowatt-hours battery, a relatively large capacity for a self-charging hybrid. This difference is clearly reflected in acceleration performance. The 3008 takes 10.2 seconds to reach 62 miles per hour from a standstill, while the Austral does it in just 8.4 seconds. When merging onto a highway, this extra power makes the Austral far more effortless to drive. What about fuel economy? In urban, suburban, up to 100 km per hour highway, up to 130 km per hour highway, and combined, the 3008 achieves only around 80% of the Austral's fuel economy in every phase. As expected, the effect of a high-output motor and a high-voltage, large-capacity battery is immense. This clear performance gap is likely why Renault proudly markets its system as a full hybrid, while Peugeot more modestly calls theirs a mild hybrid. However, this is not to say that Peugeot's system is ineffective. Let's compare the ICE and hybrid versions of the Peugeot 208. In urban, suburban, up to 100 km per hour highway, up to 130 km per hour highway, and combined. Even as a mild hybrid, the ability to launch and drive at low speeds without using a single drop of gasoline, combined with reusing energy from regenerative braking, allows it to far surpass a conventional ICE vehicle in fuel efficiency. Previously, this channel received the following question. In turbocharged hybrids like the 3008 and Austral, when you exit the highway and transition to city driving, the system switches to EV mode, shutting down both the engine and the coolant pump. If the coolant flow to a scorching hot turbine shaft stops, wouldn't that lead to shaft seizure? Rest assured, both Peugeot and Renault equip these engines with electric coolant pumps. Even after the engine is shut off, coolant continues to circulate to vital components as needed. However, Don't get too comfortable just yet. While measures are in place to prevent turbine seizure, this channel has no data regarding the long-term reliability of the hybrid system as a whole. Ultimately, only the owners and service technicians know the real story. Thank you for watching. If you enjoyed this video, please consider subscribing to the channel. We'll see you in the next video.